Okay, so for our enrichment topic for our last lesson for the fourth quarter, and also for the entire lesson and our entire subject here in geometry, plane and Euclidean geometry. So it's going to be equal. It's going to be about the equation of a circle. Okay, so the equation of a circle will be discussed in analytic geometry, in your analytic geometry in grade 10 or in your advanced mathematics, but we're just going to try to introduce, okay, one of the four conic sections. So we have you're also going to be introduced to the four conic section: the ellipse, the hyperbola, the parabola, and the circle. The most basic is of course the circle, okay, and we're going to try to introduce the general formula and the standard formula for this given figure that we have. Okay, so the general formula for finding the equation of a circle on a Cartesian coordinate plane is equal to x squared plus y squared plus cx plus dy plus e is equal to 0. So how did this happen? Okay, so if we graph a circle on a Cartesian coordinate plane, okay, it's a unit circle. Let's say for example it's a unit circle. So that means it has a radius of 1. Okay, so if it's a unit circle, so therefore its general formula is going to be x squared plus y squared is equal to r squared. And since the value of r, our radius here for the circle is equal to 1, therefore its general formula is going to be x squared plus y squared is equal to 1. Okay, so where did the cx, dy, and e come from? Okay, so it comes from, okay, if we have a different center point. Let's say for example the center point is not at 0. Okay, so this only happens, guys, okay, when the center point for our circle is at 0. Okay, but if for example it's on a different quadrant. Okay, let's say for example it's here on this different quadrant, or here, or let's say for example the center is not at the origin of the coordinate plane system. Therefore we're going to have to solve for a binomial. Okay, so therefore that's how the cx and the dy comes or originate from the equation. And the e, okay, the e is the answer here from the other side of the equation on the right side. Okay, so if we transfer that to the left side, so this is going to be x squared plus y squared minus 1 is equal to 0. And again, this e here, the e here is arbitrary. It can be positive or negative since it's a variable. Okay, so solving for the value of the radius, okay, let's say for example we do not know the value of the radius. We can solve for the value of the radius using this distance formula here. Okay, so guys, you have, I think, encountered the distance formula during our enrichment lesson on the first quarter, but for here we're going to try to apply that concept on the level of circles. Okay, so to do so, we can use the formula for the distance. We're finding the distance between point E and point A. That's essentially it. Okay, and when we find the distance between these 2 points, then we will have created a radius. Okay, since it's been this distance here is found on this circle, on circle E. So this is going to be equal to r. Okay, r is equal to this. Okay, so solving for the value of r. Okay, so solving for we first have to identify the values for the coordinate x, y, and hk. Okay, so the x, y, and hk, these are our coordinates for the given figure that we have here. Hk, okay, h and k, these are these coordinates. Okay, so these points, okay, are the coordinates for the center. Okay, so this is the center of the circle, and xy is a point on the circle, or a point on the circumference of the circle. So if we have here 3, 4, then h is 3 and 4 is k. And if we have here 5, 2 for the coordinate for point A, so x is 5 and y is 2. So therefore we can now use the formula x minus h squared plus y minus k squared. So this is going to be equal to r is equal to x is going to be 5 and h is going to be 3 squared plus y is equal to 2 minus k, which is equal to 4. So this is the distance formula working for us, guys. So it's going to be 5 minus 3, so it's going to be 2 squared, plus 2 minus 4, so it's going to be negative 2 squared. So r is equal to 4 plus 4. And 4 plus 4 is simply equal to 8. And what's the square root of 8? We can factor 8 to 4 times 2. And therefore, we can put the factor of 4 outside since it's a perfect square. Okay, so there you go. So we get that the value of r is equal to 2 square root of 2 units. Okay, so that's simple using the distance formula. Okay, so given here, guys, now that we know that the value of r is equal to 2 square root of 2 units, can we now find the standard equation for this given circle? Yes. Okay, so we can find the standard equation using this formula. X minus h squared plus y minus k squared is going to be equal to r squared. So since we want to find the standard equation, so we just put here x, okay, we simply write here x, and then since this is h and this is k, then we can write here 3 for our h, and then y minus 4 for our k is going to be equal to 2 square root of 2 squared. Okay, so solving for the value of x here and y, and for the standard equation of the circle, we have x squared minus 6x plus 9 plus y squared minus 8x plus 16 is equal to 2 square root of 2 multiplied by 2 square root of 2. So this is 2, and 2 times 2 is 4. Okay, and 4 times 2, so that's going to be equal to 8. Okay. Okay, so solving now for the values of this figures that we have here. So this is going to be equal to x squared plus y squared minus 6x minus 8x, and then positive 9 plus 16 minus 8 is equal to 0. Okay, so 9 plus 16 is 25, and 25 minus 8 is going to be equal to 17. Okay, so x squared plus y squared minus 6x minus 8x plus 17 is equal to 0. So this is the standard equation of our circle given that the center, okay, given that the center HK is equal to 3 and 4. Okay, and given that we have here these points right here. Okay, so that's the standard equation. Okay, so let's try to solve for some more problems. Okay, so given that that the center of circle G is 3, negative 2, as negative 3 and 2. Okay, so you have your negative 3 and then positive 2. So this is the center of the circle G. Okay, and given that the radius r is equal to 15 square root of 2, we are going to find the standard equation of the circle. Okay, so this is very easy. Okay, we're given the radius 15 square root of 2 meters, and the center, which is hk. Okay, the center hk is negative 3, 2. So we can go ahead and write the formula for finding the standard equation of a circle. So that's x minus h squared plus y minus k squared is equal to r squared. And we know that the value of h is negative 3, so that's going to be positive 3 here, plus y minus k, and k is 2. So it's going to be y minus 2 squared is equal to r squared. So that's going to be 15 square root of 2 squared. Okay, so it's going to be x squared plus 6x plus 9 plus y squared minus 4y plus 4. Is that right? Is equal to 15 square root of 2 multiplied by 15 square root of 2. So it's going to be 2 times 15 times 15 is simply equal to 225 times 2. So that's 450. Okay, so equal to 450. Okay, solving for the standard equation, we have your x squared plus y squared plus 6x minus 4y plus 9 minus 4 minus 450 is equal to 0. And 9, okay, 9 minus, okay, wait a minute. Positive 9, okay, so this is also plus 4. 9 plus 4, okay, and then minus 450. Okay, so that's going to give us negative 437. So the standard equation of this circle right here is going to be equal to x squared plus y squared plus 6x minus 4y minus 437 is equal to 0. Okay, so that's our standard equation. Okay, next problem. So given that the center of a circle is at point 6 and negative 8, and it passes through one of the points on the circumference of circle Z. Okay, so there's a point there and it's negative 1, negative 3. So we are asked to find the standard equation of the circle. So we can see here is that since this is the center, this is H, this is K, and this is X, and this is Y. Okay, so first we need to solve for the radius of the circle. Okay, so the radius is going to be equal to the square root of x minus h squared plus y minus k squared. Okay, since we know that the value of x, okay, the value of x is equal to negative 1 and h is 6, okay, so minus 6 squared plus y, the value of y is negative 3 and k is negative 8, so that's going to be plus 8, okay, squared. Okay, and then next is negative 1 minus negative 6. Okay, so negative 1 minus 6 is going to give us negative 7. Okay, so negative 7 squared plus, okay, 8 plus negative 3, that's going to give us 5. Okay, 5 squared. So this is going to give us 49 plus 25. Okay, and 49 plus 25 is equal to 74. And the square root of 74 is simply equal to the square root of 74. So that's the value for r. To solve for the standard equation, so we just simply write the general equation first for the circle Z that we have here. So it's going to be x minus h squared plus y minus k squared is equal to r squared. Now we know that the value of h is equal to 6, so that's going to be 6 minus x minus 6 squared plus y minus 8. So since it's negative 8, that's going to be positive 8 here. Squared is equal to r squared. Okay, so that's square root of 74 squared. So this is going to be equal to x squared minus 12x plus 36 plus y squared plus 16y plus 64 is equal to 74. Okay, so this is going to be equal to x squared plus y squared minus 12x plus 16y. Okay, and then we have your 36 plus 64. Okay, so that's equal to 100, and 100 minus 74, that will give us 26. So this is 100, then minus 74, so that's going to give us positive 26 is equal to 0. And this is the standard equation of our circle. X squared plus y squared minus 12x plus 16y plus 26, okay, plus 26 since this is 36 plus 64, and then minus 74 is equal to 26 is equal to 0. And that ends our lesson for module 5. Okay, thank you guys for listening for our last module.